All right, guys, this is the fourth page. So this is the back side. It just had number 1 and number 2 on it, looking at word problem and then domain and range. So we went over these in class. Just to go over it again, we're talking about, so baseball's being hit and then hits the ground. The highest point, so for A, is going to be your vertex. So anytime you use, it says how high or how low something gets, it's going to be vertex. To find vertex, we do negative b over 2a. That gives you your x value, get an answer, and then plug it back into your quadratic equation to find your y value. And the y value is what we really want. So on this, it would be negative 40 over negative 32, which is 1.25. So then I'm going to plug this 1.25 into the equation for t, because that tells me at 1.25 seconds, my ball is going to be at the highest part. So put that on a calculator, work it out, solve it, you end up with 27. All right, part B, the catcher tries to catch it but loses it. So how long does it take for the ball to hit the ground? So here's the ground. I want to know how long did it take from when he hit it, go all the way down and hit the ground. So we're looking for time. So anytime you're looking for how long until it hits the ground or how long until it resurfaces, things like that, you're going to be using quadratic formula to solve. Okay, so my equation again is this up here. So if we're going to put this into the quadratic formula, we'd have negative 40 plus or minus 40 squared minus 4 times negative 16 times 2 all over 2 times a, which would be negative 32. So we're going to start with simplifying this underneath a radical. All right, if you put that on your calculator, you end up with 1728 over negative 32. Now, normally this is where we go off to the side and we simplify this, but when we're talking time, we actually want numbers, not radicals. So if I do that on my calculator, I end up with this, negative 40 plus or minus 41.56921938. We want the whole entire decimal. So then here, I'm going to look at this. Quadratics always get two answers. So I want to think logically here. If I have a negative 40 and I add a 41, so negative 40 plus 41, that would equal a positive 1. And then a positive 1 divided by negative 32 is going to give me a negative answer. Negative time doesn't make sense. So I'm going to subtract. And if I subtract and then divide by, if I subtract, I get a negative 80 something, 81 point whatever. Then divide that by negative 32. Again, this is all calculator work. When I do that, I get 2.549. So this is my answer, 2.549. That's how many seconds it takes for the ball to hit the ground. And last, this one is just plug and chug. You're just going to plug in 1.5 into your equation. And when you do that, you end up with 26 feet. That's the easy one. All right, domain. That's from left to right. So if this were to keep going forever and ever and ever, this would keep getting wider and wider. So my domain is going to be all real numbers. My range is bottom to top. So here up. Well, this graph clearly, this red parabola here, clearly doesn't go below this point right here. Since range is your y values, and I'm going to focus on this number right here. So we're going to include it. That's why we do bracket. Negative 7.125. And then this goes up forever and ever, so positive infinity. Another way to write that would be y value. All my y values are greater than or equal to negative 7.125. Either way would be correct. All right, and then this one here. So domain, left to right, this is going to keep on going. It'll keep getting wider, so that's all real numbers. And range, so I know we have these points here, but there are other points on the graph that go higher, like all of these points, and all of these points right here go lower than this point. So my range is also all real numbers. Remember, when talking domain and range, if you're not sure, all real numbers is a pretty safe bet. Okay, the only time you're going to have some restrictions is when you have a parabola. All right, that's the end of this page. Go on to the next one for